Okay, I actually finally watched Professor Dave's debunking of the quantum music healing video. And so I just wanted to make a response because second response in more detail. Um I mean, I really enjoyed his video. I thought it was very entertaining and also kind of fascinating because his view is the materialistic view that mind is a um, byproduct of matter, and that there's no evidence to suggest that there's some kind of universal mind to the universe, and also that sound has nothing to do with light because sound exists in the medium of air, and um, it's a different kind of wave than light, being a, I don't know if you call it like a transverse wave or something. And what else did he talk about? He talked about the Bohr's. The video he was debunking had Bohr's rule in there for the um, radius of the atom and based on the electrons, and the emission of photons and how that's related to the Ritz-Rydberg um, principle of, and so that's what really got me intrigued because he was debunking this idea that the guy was saying, well, you have 1 over x and then you have x squared or 1 over x squared, and that's equivalent to the emission and um, absorption of photons. And you know Professor Day was like, well, um he's like, yeah, but that's got nothing to do with um music. And then when the guy got into music theory, he's like, look, you're showing G sharp instead of G, um when you're, and then it's a totally different chord, and if you play C to E as a chord and then you transpose the chord, it's the same chord. So it's like E G C is the same chord as C E G. Um, yeah, technically that is true, but there's a difference between chords and intervals. And so that was probably the most fascinating part of the video, is that Professor Dave, he got really irate, and my guess is that he might have, like, even if it was on a subconscious level, he might understand that the transition frequencies of the Ritz-Rydberg law are actually non-commutative, and this was what Heisenberg discovered. This was his big discovery. And so then you realize in music theory that, as the guy in this video was pointing out, C to E is a major third, but then C to E from the octave, so the octave C down to E is a minor sixth. And so the guy was trying to point out that that means that the intervals are non-commutative. Well, I mean, he didn't use that term, obviously. Um, but and then the other point was that Professor Dave was like, well, it is interesting to study how major and minor chords are associated with, like, sad music for a minor chord, and a major chord is happy music, and why is that? How does that relate to biology, and how is that different for different cultures? And and he said he made the claim that it's been proven that some cultures think a minor chord is happy music and vice versa. Um, that claim actually is not it's not really true because there was a study done of a tribe in Africa that had no contact with Western music, and they discovered that the tribe made the same exact connections between a major scale as being happy and then a diminished chord being scary and a minor chord being sad. And so that study actually kind of prevented presented evidence to the contrary that the emotions are in fact universal to the tuning. And then you get into um the interesting aspect that the minor intervals are again non-commutative in the sense of being undertones. And so when you have undertones and overtones, you're no longer in the realm of harmonic ratios. So the harmonic ratios are what he was referring to when he said a chord would be the same whether you play it backwards or forwards. It's arpeggios. And I mean, I can speak from experience because I trained in music. So, I trained in arpeggios and scales um but I mean, that's where you get into modal music, like when you're playing jazz. There's a famous jazz book by Yusef Lateef on the modes, the different modes, and this influenced Miles Davis and getting into non-Western music. John Coltrane was heavily influenced by Yusef Lateef, and I actually learned about this from a street musician, a guy who was on disability for lead poisoning, and we started playing together, just free jazz. We just started freely improvising, and then he told me about Yusef Lateef, and then it turned out Yusef Lateef actually taught at my school at Hampshire College, and that brings me back to quantum physics because it's pretty ironic that I went to Hampshire College after going to a Christian high school and middle school that was in the Covenant denomination from Sweden. And I didn't know this at the time. My family, my dad's side, had gone to this Covenant school. And my dad, good morning. Thanks for joining in. My dad's, let me see if I can remember this right because it's kind of interesting. So my dad's mom's sister taught at this Swedish Christian school, and she taught Latin and typing, and taught Latin and typing for like decades. And so her last name was actually Swanberg because she married a Swanberg, but she originally was a Peterson because that was um my dad's mom's maiden name was Peterson. And then the Swanberg family that she married into had a famous author of a biography. He won a Pulitzer Prize actually, and he lived in New York City. And so my dad was buddies. He was buddies with this famous author, the Swanberg author, through that family connection. So I'm getting off, on a sidetrack here, but I'm just pointing out that I went to the school that I had a family connection to. My dad had gone there for a year, and then my aunt had gone there, and then um, I have a neighbor who is tied closely to there also, and so it's like this Swedish Christian community that I was a part of, that I'm still a part of, and through this covenant denomination. And I had no idea that the covenant denomination was actually kind of a radical denomination that was challenging the Lutheran Church, and they're more so they believe more in like direct religion, direct spiritual experience as religion instead of some kind of state government religion, which I guess the Lutheran Church was actually like a state religion. I don't know the details on that, but I actually just started reading a book on that. Goes into that more probably by Dr. Robin Walsh, and she's um the book was published by Oxford, or no, Cambridge, I think it is, and it's about early Christian literature. And so, anyway, to get back to quantum physics, so I graduate from Minnehaha, and then I go to Hampshire College, and Hampshire College is like this hippie experimental college that was set up in the Amherst Valley. And so it's called the Five College Valley because these other kind of like Ivy League type schools set up Hampshire College. So you have Amherst College and Smith College, and those are both basically like Ivy League schools. Um, and then you have Mount Holyoke, which is an women's college. I think it's still a women's school. And then University of Massachusetts Amherst. Um, and then Hampshire College. So that's the five colleges of the Valley. And I took classes at Smith College, and I took music composition there and piano lessons. And Yeah, so my piano teacher was this old school Hungarian lady, and she literally had me use one finger, and she's like, "Feel the energy at your," and it was really weird because it was like this, almost like it was like Hungarian magic or something like. And then I was reading this book about Bartok on by Erno Lenvi, and that's what got me. I took a math and the arts class, and I wrote a paper on the Fibonacci number series and music theory because that was the claim of this Erno Lenvi book, that the Fibonacci number series is directly built into music tuning. And he claimed that Bartok was using this to compose his music secretly, and that Bartok had this system of pulls. So he was using the undertones and overtones essentially, and he created this. I think it was, I can't remember what he called it, but it's like a master chord that had like two tritones in it. And of course, if you look at the tritone, it equally divides the octave. So when you have two tritones, I guess it was would comes out to be two major thirds. So the example that Professor Dave gave was, he's like, well, he's using G sharp, so the tritone would actually be F sharp, not G sharp. Yeah, I can't quite remember the Bartok chord how it worked out, but and then you get into jazz tuning essentially when you have ninths and elevenths, you're essentially dealing with the 11th, I think it's the tritone, maybe, because you're dealing with a flat. A ninth is actually the major second or minor second, and then the 11th would be the um okay, ninth. Yeah, it's getting complicated here. So you have a flat seventh, and then an eight is the octave. So the ninth major second, so 10th is the third, 11th would be the fourth. Yeah, so if it's an augmented fourth, augmented 11th, that would be the same as a tritone. So you can see where when you extend the chords in music theory, you essentially are able to recreate the chromatic scale, which then gets you into the ultimate level of dissonance in terms of tuning. And this was another um, sort of like joke or a moment in the Professor Dave video was he was talking about the Moonlight Sonata and Beethoven's Fifth or something like that, and because the music video was like, well, Beethoven's fifth is a tritone, and that's like really sad or scary music or whatever because it's the most dissonant. And and then Professor Dave's like, well, why is he playing Moonlight Sonata, and not because there was a total disconnect between the video and the content of the guy making the video. My guess is that the video was probably like AI generated. But anyway, to get back to quantum physics, so the most interesting part of the Professor Dave video was when he shows this Bohr equation, and he's like, "Yeah, it's a inverse, and you have inverse in music tuning, but it's not the same thing." And and then his other point was like, "Well, you're measuring frequency, but but frequency of what? Because in physics, the frequency is a cycle of something. It has to be a cycle of something, and in terms of time, it's measured in hertz. Well, that's where it gets interesting because when hertz assumes a symmetric spatial measurement for the time, for the period of time, and that's kind of the problem is that when Juliana Mortensen points out that when Planck was converting frequency for light into joules as energy, he canceled out the time, so he just had the frequency. But the way he canceled out the time was he was assuming a symmetric time frequency it as hertz. So the hertz is considered a dimensionless um, unit in radians. And the problem is that when you have non-commutative time and frequency, then you cannot just cancel them out because the order of direction changes the value. And this is what that music healing video was like, hinting at without maybe even realizing it because it's a subtle music theory truth, and only Alan Khan goes into that detail about the perfect fifth being non-commutative as an overtone and undertone, and that's different than being a symmetric inversion of the ratio, which is what because you have to change the root tonic when you convert from the perfect fifth to the perfect fourth, because normally like um the perfect fifth as an undertone is actually a perfect fourth as an overtone, but the perfect fifth is then inverted in terms of the mathematical ratio. So as a mathematical fraction, you have 2/3 and 3/2, and they're both a perfect fifth. But in terms of the pitch in relation to the root tonic, the 2/3 is a C to F undertone, and the 3/2 is a C to G overtone, and they're both a perfect fifth. But then when you double the undertone, then it goes from 2/3 to 4/3, and that's when you get the perfect fourth. And so, as I point out in my published academic article, this means that the even in Western music theory, this is rarely acknowledged that there's a difference between harmonic ratios and undertones and overtones. And only Alon Khan has really pointed this out that the truth of music is actually this non-commutative non-locality because of that um, change of the root tonic. And if you maintain the same one in terms of number as a root tonic, then you have this infinite, what Pythagoras called an infinite spiral of fifths. So now that we've established the non-commutativity in the music theory, the infinite spiral of fifths then implies that there's a transduction between sound and light because it turns out when you go back to the Bohr equation, the the transition frequencies of the Rich-Rydberg principle are actually non-commutative frequencies, and this is what Heisenberg originally discovered. So that's Alon Khan's big point, is that the form of music is actually formless, as because of this non-commutative secret of the transition frequencies of light, of the emission and absorption of light. So the music video that this guy created, this fake music healing quantum video, actually does, like, it's like adjacent to the actual non-commutativity. Like, he's dabbling in areas that definitely are connected to the whole issue of non-commutativity, but I think the guy making the video didn't even, understand the issue at hand, because it's like you have to dig a little deeper. So I was reviewing the quantum mechanics book, which I didn't I didn't realize it actually has a chapter on Bell's inequality. And he because I was looking up Bohr, I wanted to see the Bohr equation and how that was connected to the transition frequencies. And but essentially he has a great chapter where he starts off, he cites Henry Stapp, and I'm like, oh, if he's citing Henry Stapp, because Henry Stapp was, his whole focus of his research was on quantum consciousness, and this idea that there is some kind of proto consciousness inherent to quantum physics, and it's related to Bell's inequality. And so, of course, Professor Dave, I don't, he probably doesn't even know about that, because when he was talking, he's like, I don't remember quantum physics. And then he was talking about high school, what he learned in high school. So, I think obviously he's probably, I don't even know if he's taken quantum physics like on a university level, because usually it's an advanced class that you would only take if you're like specializing in the area. But the reason I took it was because my professor believes that, because since quantum physics is the foundation of science, then it should be your first physics class, because it's important to get the proper foundation to reality. And this is the irony that I was realizing, because my quantum physics professor also practiced Buddhist meditation. And so here I was, transferring from like a Christian private high school to a hippie experimental college, and not realizing that the quantum physics class I was taking was taught by somebody trained in Bell's, or David Bohm's physics, and secretly practicing Buddhist meditation. And so I had gone into religion, but from the exact opposite perspective, from like a far science, extreme science, rediscovery of religion in extreme materialistic science. And so, like, in my first year of college, I just like completely short circuited the whole materialistic science debate that most scientists are really stuck in. That you have to, in order to be a real scientist, you have to be a materialist and think that the brain came out of matter. But so, at any rate, to get into Bell's inequality, then yeah, this book, he goes into, this guy was a professor from University of Minnesota Duluth, Thomas Jordan. And so he just like reiterates this experiment that Henry Stapp develops, and that leads you right into Bell's inequality, because he's like, you have you're changing the magnetic moment, and that there's, you change it in space, the particles can be separated far enough that signals traveling at the speed of light do not have time to bring information. And he goes on, and then he says it should make no difference which change is made first. So that's the non-commutativity. Um, and then he's saying the probabilities calculated from quantum mechanics are evidently inconsistent with the assumption that the direction change made does not change the values. and the direction change does not change the values in the, he's talking about east and west. These are like on the in space at distances too far for the speed of light to have made any kind of signal connection. To make this argument, we have to assume there is a value for the projection of each magnetic moment in each direction. So the so basically, he's pointing out that they started to realize that this was the debate between Niels Bohr and Einstein, and that's just what Einstein then published it as the Einstein-Podolsky-Rosen experiment, or what do they call it? The EPR. But that gets you into Bell's inequality because basically Bell's inequality was saying that if Einstein, Podolsky, and Rosen are correct, then Bell's inequality must hold. But um, so then they started developing all these experiments, and this is what my own quantum physics professor was involved in. And he was the National Science Foundation administrator through MIT for the guy who got the Nobel Prize in 2023, I think it was, for Bell's inequality. And his name, let's see, it's slipping me at the moment, but yeah. So Herbert J. Bernstein was, directly. Oh, Anton Zeilinger. Okay, so basically, they proved that you have this instantaneous. They call it a correlation, but Jean Brumont's point is that that correlation is an action at a distance because you're having an instantaneous change in the values of the magnetic moments, or you could also do it with the polarization of the photons. But these various quantum actions that can be changed faster than the speed of light and instantaneously. And so the um the standard physics, like the materialistic model, it's trying to claim that this proves that only probabilities are the truth of reality, that there's an inherent probabilistic uncertainty at the foundation of reality, and that we cannot know the foundation of reality, and that there's just this probabilistic math that we have to rely on, and that's it. And that's a pretty wild view because even Einstein disagreed with that view. And um, so you have there's this great um, like this deep irony at the heart of science about whether science is really rational or is it just like probabilistic based on randomness. And the non-commutativity argument is that it appears to be random, but it's actually not random. And this is what Sir Roger Penrose even believes also. He says it seems to be random, but actually because you have this complex time where the time based on the square root of -1, the phase is this discrete non-local time. And then Penrose is like, well, he's not good at the non-commutative mathematics because you're dealing with matrices and um so that's what Basil J. Haley was completely focused on. Was like, well, how do you develop this non-commutative um mathematics and tie it into relativity, and working with David Bohm. And yeah, um so it is like that. So, and then of course, how does it connect back to sound and listening? Because in physics they're assuming that the source of music is this external measurement as the vibrations of air, for sound. But that's not the same as listening, because listening is not the same as an external measurement. Listening is biological perception. And so when you are relying on undertones and overtones as a listening process, then you realize that there's this inherent quantum physics to the listening process. And that's what article, my academic article gets into that a bit more. I have some quotes from some biologists who studied the phenomenon of auditory perception and listening and how that can be actually, um, a superluminal um, resonance. And that's what Andrija Puharich's research was focused on too, because he tied it into ultrasound. And um, that's something I discovered in my own research and with like tinnitus research, is that the highest sound you can hear externally actually resonates internally in your brain as ultrasound. And when you have that ultrasound phenomenon, then all of a sudden you do have a mechanical transduction into electromagnetic energy. And so that's the connection that Professor Dave, he would prefer to ignore it or just like say, "Oh, don't think about this." and and then my interest is, or what's the broader implication of it, of um repressing this Pythagorean infinite spiral of fifths as this transduction of energy from the process of listening to overtones and undertones as meditation with your eyes closed, and how it's connected to biophotons um and of course Stuart Hameroff and Roger Penrose have delved into this. And then Professor Dave, he has this video recently attacking Professor Dennis Noble of Oxford University, and he's like, Dennis Noble is a clown. And I started listening to the video, but he didn't seem to realize that Dennis Noble had been an advisor to Richard Dawkins' PhD thesis. He was one of the, you know, crit- critics, or he was like on the academic committee that advised the PhD project of Richard Dawkins. So he's really not a. You can't say he's a clown, because if you follow, claim to like be a materialist that follows Richard Dawkins, then all of a sudden you're like, okay, well this guy, approved Richard Dawkins, so he's got to be qualified to like critique Richard Dawkins right away. You can't just dismiss him as a clown just based on that paradox. Um. Anyway, so yeah, but another thing about Dennis Noble is he focuses on the microtubules and the role of microtubules in the cell, and in relation to water, and how the you get a larger information organizing process of in biology due to this microtubule interaction. And then the microtubule course is directly tied to the ultrasound and biophoton biology that Stuart Hameroff was researching, and corroborated by Anirban Baniopahe in Japan. And I've corresponded with Anirban Baniopahe. Um, so yeah, there's a lot of like fascinating details that I'm sure Professor Dave has no interest in delving into, because he seems to be quite focused on his own research projects. He's posting like YouTube videos about his whatever he's been focused on in his own research. And of course, that's the way science is. I mean, everybody's specialized, and so it's really easy for scientists to like get all upset and just dismiss other scientists as being quacks or something. And like for example, Carlo Rovelli, he worked with Alon Khan, but then Carlo Rovelli says that quantum biology is, BS. Like he literally said BS, and he got mad. And I find it quite fascinating that these, like Professor Dave and Carlo Rovelli, they seem to be really mad about this whole concept of quantum biology where you're combining physics with biology. And of course, I mean, it's easy to get mad because then you're lapsing into the new age woo woo, and you don't want to be woo woo, but I think that Professor Dave seemed to get the most mad in this video when I think he subconsciously realized that there is this non-commutative connection between the transitional frequencies of photon emission and radiation and the inverse music intervals being non-commutative. And Alon Khan's YouTube lecture, Music of Shapes, or it's been posted on YouTube, but actually he does it as a live stream also, but that's the whole focus of his video, is talking about this secret truth of music being the non-commutative time frequency. And so then, Professor Dave's like, "Well, frequency of what?" But in quantum physics, they call it proto consciousness, and they're saying this is the foundation of reality, and this is what Roger Penrose says. And Roger, even though Roger Penrose is whatever, like 95 years old, I mean, he's completely lucid. He's completely articulate and lucid, and it's easy for scientists to ignore him or try to dismiss him because he's delved into quantum biology and um you know but he calls it proto consciousness because that's what quantum physicists called it. That's what bernard Bernard de Espinay, I think he coined that term, proto consciousness. And I read Bernard de Espinay's book, Veiled Reality, and he won some, I think he won like the Templeton Award or something like that. And of course, in science, it's like, wait, if you get the Templeton Award, that just means you're interested in religion as a scientist. And so a lot of scientists see that as an excuse to dismiss a scientist. Um, so yeah, it's like, just it's a real debate in science. Like, can you have spirituality and religion and coexist? Like, be a scientist, and that's where you get into philosophy of science. And most scientists, they're just like, shut up and calculate, like, seeing is believing, and you got to have repeatable results. But at the foundation of quantum physics, it's just not true that the non-commutativity, it's what in yoga meditation they call ever fresh, ever new. That's the phrase that Yogananda used in his book, in his biography, or no, I think it was one of his other books I was reading about 30 years ago now. And anyway, so yeah, it's a fascinating realm, and I enjoyed. It took me, I couldn't just like sit through and listen to Professor Dave's video all at once because he does get really emotional, and obviously it's a area of research that I'm focused on, so it's not exactly fun to see somebody completely just dismiss it and not want to have anything to do with it. But on the other hand, it was very fascinating because the video that he debunked, did it like flirted it flirted with the issue of non-commutativity. And I think that Professor Dave, like, on some kind of intuitive level, he realized that there was something there. So he got like super irate. And that was like fascinating to experience that. Jean Chiron is another Jean Chiron. He's another quantum physicist in France that went into spirituality, and then he ended up getting funded by the Moonies. Like, I found books of his that were, yeah, this book's published by the Moonies, Paragon House. And so you have this weird, like, scientists getting, you know, like, I'm sure Jean Chiron is not a Mooney, but he's trying to get his book published, and that's the Moonies were wanted to, because it's kind of supports their cult. viewpoint, I suppose. I mean, and yeah. So the in terms of the ecological crisis, though, for in my opinion, like David F. Noble was more accurate. He was an MIT history professor, which is you know the opposite of woo woo, and he was delving into this problem of Western science destroying life on Earth, and he realized it was tied into the Platonic philosophy of the mathematics as a structural problem of science, and so that's um I kind of like picked up where he left off because he took it back to the ninth century and he argued, well, John Scotus Erigena got Platonic philosophy from the Muslim scholars, and then John Scotus Erigena passed it into the Benedictine monks, the Carolinian monks, the Carolinian Empire in the ninth century, and from there it just like Platonic philosophy then created modern science through the monasteries, and so there's always secretly been this connection between science and religion that mainstream science tries to suppress and ignore because they want to be materialistic and assume that rationality is against religion because religion historically, I mean, you had the like aristocrats in Europe and the church owning all the land, and then you had Republican revolutions and Democratic revolutions against the feudalism, land ownership, and with the church and all that. And so, yeah, these are definitely like uh, issues that people can spend a whole life focusing on. But when you look at how science spread around the world, this westernization of the world through neocolonialism, um, then you are confronted with the ecological crisis. Like right now, they're having the global COP conference in Baleem in the Amazon rainforest, and it's like, well, we are rapidly destroying the Amazon rainforest, and can we stop that? And the U.S. government is not taking part in the conference. I think the governor of California is there as sort of like a counter president kind of thing. But the problem is that over 50% of physics is funded by the U.S. military for the U.S. military, and obviously the U.S. military is the biggest destroyer of the environment of biology, and so you get this phenomenon where physicists are ignoring the ecological crisis or downplaying it, or not not really talking about it, or and someone like David F. Noble realized that the ecological crisis is actually symptomatic of the wrong mathematics that's driving science. And he moved back to Canada because he got fired from MIT, and he just kind of he did activism at his school in Canada, York University, but there was only so much he can do, as one person. And he got his books published, and they just kind of got ignored, I suppose. And then, that was it. There's like a few academics that have paid attention to him, and then he left his body, and it was all over, And then you have science continuing. So obviously, it's difficult for somebody to psychologically realize that, or to accept that the whole scientific project has been inaccurate at its foundation. because of this wrong mathematics that it ignores the non-commutativity, and that mathematics came out of the wrong music theory. So it's like a huge interdisciplinary realm, and then you get into non-Western alchemy when you take meditation seriously, and that's a whole nother fascinating realm. It's like nobody's gonna want to even delve into that if they're not able to accept the proposition that non-Western meditation is the accurate foundation of reality due to non-commutativity. But that actually was the claim of Eddie Oceans, and Eddie Oceans was no slouch. I mean, he he has a book chapter in this book here, and this research center was tied to the CIA and MK Ultra, and that's a whole nother problem. Is when you get into the paranormal and spiritual abilities and powers, then you all of a sudden you start getting into what one of my teachers called spooky looky land, and essentially, you know, like Andrei Puharich, his whole claim was like, well, Uri Geller, he has to debate with James Randi of Psychop, but that whole debate is a scam to cover up the military intelligence, and James Randi was actually like military intelligence or something like that, as a way to cover up this deeper level of using the paranormal for spying, for psychic spying and stuff. Anyway, I'm gonna leave it at that. I don't know if Puharich was correct about that, but it's kind of interesting take on it all.